Okay, let's go. Rearranging fruits. Hard. You have two fruit baskets containing n fruits each. You're given two zero-index integer arrays, basket 1 and basket 2, representing the cost of fruit in each basket. You want to make both baskets equal. To do so, you have the following. You can use the following operations as many times as you want. Choose two indices I and j, and swap the ith fruit of basket 1 with the jth fruit of basket 2. The cost of the swap is the minimum of basket 1 at I and basket 2 at j. Two baskets considered equal if sorting them according to the fruit cost makes them exactly the same baskets. Return the minimum cost to make the baskets equal or negative if impossible. And then the examples here are 4, 2, 2, 2, 2, 4 and 3 2s, 1, 4, 1, 4, 1, 2. You swap the 2 and the 1 to make them both include 4, 2, 2, 1. And the cost of that swap would be the minimum of the two values that were swapped, which is 1. And then second one here is not possible because there's like 1, 4, and 1, 5, and you can't have both baskets include those values. Alright, so I thought about this for like maybe 20 minutes, 15 minutes before going on. And to be honest, this seems like a pretty straightforward one compared to some of the other hard ones that were impossible seeming. So I'll just do the trivial case first, which is impossible. Trivial impossible case, and that is only possible to balance if every value is has even frequency. So if there's only 1, 4, 1, 5, there's no way that you can have both baskets include a 4 or include 5. So how should I figure this out? I could maybe make a total frequency counter. Actually, can I do counts? Can I make a counter out of multiple things? Like multiple sets or multiple lists? Counter initialize from an iterable. Can I update a counter? Using counter update. Okay, so I can make a counter out of one of the lists and then update and then check if it's even. So let's say counts is equal to the counter made from basket 1. I could also have just made like a new array that includes both. Counts.update basket 2 for every value in counts if the frequency of that value, which just counts at that value, is an odd frequency, then return -1. Otherwise return 0 for the time being. Just to do a quick check on test case 2. Okay, test case 2 correctly identifies that as being impossible. Okay, so I initially thought this was going to be straightforward in terms of like you just swap things that were unbalanced that need to be on the other side with each other, and then this does kind of minimizing the number of swaps, to be honest, rather than minimizing the cost. So for instance, if I had let's say I had one basket is 1, 5, 10, and, no sorry 1, 5, 5, and the other one is 1, 10, 10, then in theory you can balance it by swapping the 5 and the 10, and that would do one swap to balance it. But the better way of doing this would be to use the 1 as kind of a carrier of the, or a barrier of the swaps. So if you swap using a 1, let's say swap the 1 and the 10, then you get 10, 5, 5, and then 1, 1, 10. And that costs you 1. And then you can swap again 1 with 5, and you get 10, 1, 5, and 1, 5, 1, 10, something like that. So now it's balanced. So there are times when you want to do a swap directly, I think, and then there's other times when you want to use like a low, really you're going to probably use the lowest cost value to swap that's evenly balanced already and make it unbalanced temporarily to do that swap. Yeah. So what are the nuances to when you want to do that is a question. So we're only dealing with unbalanced swaps that are necessary. And then for every unbalanced pair that should be, like for every pair that's there on one side, there should be something that is incorrectly there on the other side. And I think the options would be to swap them directly. So to swap one of each of those two pairs, make them both pairs be balanced, or to use a barrier where the barrier value is the smallest value that is already balanced. And the barrier is going to be reused really, because if there was like another pair, like let's 5, 5, and let's say 100, 100, and 1,000, 1,000, like you're still going to use the barrier to rebalance those. Actually, if you have a value that's 0, it's actually trivial. You just the cost of reswapping everything is going to be 0. So when do you want to swap directly versus when do you want to use the ferry value? The ferry value will cost you twice the ferry value, so it costs you the cost to using a ferry on to balance those two pairs is twice the ferry value. And the cost of balancing the pairs directly would be just the minimum of the two values. So if the minimum value is less than twice the ferry value, then use the min value. So so like what I'm thinking here is there's some min value, I'll call it m, that's balanced, and then there's some I'll call the low value w, and then there may be AA on one side and WBB on the other side. And so the cost of why did I put it here? So the cost of balancing is either the minimum of AB, so you swap AB, or 2 times W. If you use W as your ferry value. And I guess you do that for every pair. At some point, 2 times W is just smaller than all your remaining pairs. So you just do 2 times W for every 2 pairs that you have that needs to be balanced. Yeah. Okay. I think that's right. Alright, so let's go ahead and try to code this out. So what to do here? So I need to first identify what needs to be moved around. What needs to be moved around. And I could probably identify the W value, the low value that can be always balanced. I guess the W value could change as well if you have your min AB become the low value. Low value. Okay, sure. This should probably be pretty quick. I think the size of this thing is probably going to be pretty large. Yeah, 10 to the 5th. I think maybe sorting it is probably necessary. Sorting is probably necessary. Or, I mean, sorting it can't hurt. You do kind of need to know your low values. There has to be some quick way of doing this, I think. So if you, for each array, if I know the overall counts, if the value, maybe I need to first start by deducting the pair stuff from the array. So let's say array 1 is the kind of removing the non-trivial stuff. So I'll say remove already balanced stuff. And that'll be that'll be for every that's not good. I actually probably need to keep this separate. Counts 1 and counts 2 because I need to know the exact counts separately here. So I think yeah, this is counts 2 is equal to counter of basket 2. And then for every value in counts in the overall counts, I could make a set of all the values. I don't know if this seems kind of slow. Basket 1, basket 2. I don't know if I can actually create a set using this method, using, let's call it that, Python set constructor. Can I use multiple parameters? I don't think I can. I think I just use set and then update. I don't. This seems really bad. Maybe I should just use for every for value in counts 1, if the counts 1 value summed up with the counts 2 of that value, counts 2 of that value, divide by, or remainder divided by 2 is equal to 1 for every value in counts 2 if the counts 1 value plus the counts 2 of that value has a remainder of 1. I think this might be faster than creating a set of all the values from both counts, but yeah. Alright, so let's go. This seems not optimal or slow, but I'll just go for array 1. Actually, this probably needs to be constructed, huh? For every value in counts 1, I would find the difference between how many times that occurred with how many times the other one occurred. Huh. So this one, how many times this occurred versus how many times the other one occurred. Okay, so what if I did something like do removed, deducted? Removed or deducted. So if there's like a 5 and a 5, there's 2 5s, and there's no 5s on the other side. Maybe I really do need all the values in one set. Okay. Because it's easier to just go through all the values in one set and then don't have to worry about 2 for loops here. All right. Okay. This is me waving the white flag sign. What the fuck? Okay, for all values for every value in all values, if the counts, actually now it doesn't actually, fuck, doesn't necessarily include that value. I guess this was an issue before too. How did I have it originally? It counts 1. Oh yeah, it counts 1 and then update the counter. For every value in all values. Maybe I can do this. Maybe I can do this in one go. Doing one pass while subtracting stuff and checking if it's not possible. If value is all right. Waving another flag. All counts starts with. This is so bad. All counts starts with count basket 1. All counts. Maybe I should just do a default dictionary. At that point, at least it'll guarantee that I don't have to check for the key in each time. Okay. Okay. Counts 1 as a default dictionary. Can I please type? Counts 2 is a default dictionary. And then for every value in basket 1, basket 1 of that value plus equals 1. For every value in basket 2, basket 2 of that value plus equals 1. It's not what I'm doing. Counts. And maybe I'll just do an all counts dictionary call. all counts of that value plus equals 1. And then for every value in all counts, if the frequency of that value, all counts of that value is odd, turn -1. Okay. Yeah, I think definitely counter is fast, but it's just not as useful or as handy as a default dictionary here, because I want to be able to refer to a certain value as a key without having to check whether or not the key exists in the dictionary, in the array, in the counter mapping. Okay, so here, so remove the balance stuff. So I think maybe for every value in all counts, I want to make 0. So if there's like 5 10s, or say there's 4 5s in the first array and 2 5s in the second array, I just want to remove the unbalanced, remove the ones that are not balanced, or that aren't already duplicated. So I guess the bigger one, the minimum frequency gets subtracted from both, I guess. That leaves the unbalanced stuff. So kind of removed is the minimum of all counts, so no, counts 1 of this value and counts 2 of this value. And then, or say, I guess I can call this balanced. I might want to use that word later on. Cancel. Oh, cancel. Yeah, sure. So then I can say counts 1 of this value minus equals the cancel amount, and counts 2 of this value minus equals the cancel amount. And if there's none of something, then it's just cancel 0. Okay, I think that's fine. And then, so the question is this thing here. The cost of balance is either the minimum of the stuff that needs to be the minimum of the lowest and highest that is still unbalanced, where A and B are unbalanced here. So it's either the minimum of that or 2 times whatever the currently balanced thing is. So 2 times whatever the currently balanced thing is, which should be figured out in the first turn, I think. Because the first turn of balancing, you either have some super low number that is going to be lower than every other number, or you balance that super low number with that super low number is unbalanced, like AA, BB, and the 1, it's like 1 1 and then 1,000 1,000 or something like that, and that super low number gets balanced, and that becomes your low value to be used for later balancing. So it still boils down to what your minimum value of your thing is. So I think maybe I can do min val is is the minimum of all my values. No, it's not the minimum. Yeah, the smallest of all my counts. Not the counts, but the actual value. And then I'll check. I can do one balancing here, or if necessary, do one balancing here to make if it's not already balanced. So if it's already balanced, then the frequency currently of that thing is 0. So if min value is not balanced, for example, let's say it's like the min value is 1, 1, 1, let's say 5, and 5,000, 1,000, 100, 100. Use min value to balance the biggest unbalanced thing. Okay, actually, maybe there's a step here that I need to do before this. And that is just to go through and get the things that need to be balanced from each array. Things that need to be balanced from each array. So for every value in all counts, actually I should probably do this in this previous one here. So I think maybe array 1 and array 2 should be what I have left over. So if count 1 of this value does not equal 0, then array 1 dot append this value. And this is just keeping track of the overall value itself, not the frequency of it occurring. Else, if counts 2 of the value doesn't equal, so one of them has to be equal to 0, or both of them could be equal to 0 once you've removed the stuff to cancel. Array 2 append this value. Okay, so array 1, array 2 track values still unbalanced. Min value. Can I just do this in one go then? I still feel like I want to do this separately. Okay, so if min value is not balanced, min value is used to balance the biggest unbalanced thing. So what can I do here? I think, gosh. I can find the maximum thing that's on the other side. The maximum thing that's on the other side and remove 2 of it. Remove 1 of it. So I need to find which side the min value is at. Find which side the min value is at. Okay. If counts 1 of this min value doesn't equal 0, then it's on array 1. So I would need to balance it with something that's on array 2, the largest value of it. So I think I probably need a sort here. Array 1 dot sort, array 2 dot sort. So that means I need to find the biggest thing in array 2 and do a swap so that now it's balanced. I think that's always, yeah, so the min value is not balanced. So there's 2 1s on the first array. Find the biggest thing in the second array. Okay. So the biggest thing in the second array is going to be the array at 2 at -1, or the -1 from the last. So array so array 1 at the front. Oh god, it's getting so nasty, even though it shouldn't be that hard. So then I have to change the frequency, and then also possibly change the frequency, and also possibly change the array 1, array 2. Do I? If it's not balanced, then array 1 at the 0 value should be this min value. Okay. Guess that makes it a little easier to tell. Okay, array 2. So max val is going to be array 2, last value of that. And then you remove 2 of those from being unbalanced. I think, yeah. So counts 2 of the max value. And at this point, the min value should be the front of array 1. So once I do that, then the counts should go down by 2 pretty much. Okay. Counts 2 of the min value not equal to 0. Max value is equal to the last of array 1 to balance with, so counts 1 of this max value decreases by 2, counts 2 of this min value decreases by 2. Okay, I think that's fine. Okay, so now what? So the min value is the min value of all the counts. So now I know So now I know what the balancing thing is, what this lowest possible cost to trade 2 times is. So now I just need to go through all the remaining stuff and balance it based on the minimum of A and B, where A and B are the lowest values of each. It's the lowest value of one side with the highest value of the other side. Oh gosh. the lowest value of one side with the highest value of the other side each time. I wonder, the lowest value of one side with the highest value of the other side. Maybe I should just create a. Maybe I should actually create the two arrays. If I create the two arrays themselves, not dealing with the counts but the actual values. Let's see how many values there are here. 10 to the 5th. I mean, it's going to be slower. It's definitely going to be more optimal if I just deal with the frequency of the counts and handle that kind of complexity on a meta level. But it'd be so much easier if I just dealt with the actual values than the values plus the frequency. Okay, so if I just did the values, then I would do something like have my two arrays at each point in time compare which of the two arrays has the lower value, and then take out the larger value from the other array and the low value from the first array. Maybe use a queue so I can pop from both ends. 5, 5, 10, 10. So if it was something like, let's say it was like 5, 5, 200, 200, and 10, 10, 300, 300. There might be some failure costs here, like a 2. Then I would look at the 5. The min value is going to be 2 here. I look at the 5 and consider swapping the 5 and the 300. So the lowest of one array versus the highest of the other array that's unbalanced. Consider swapping them, or consider using 2 times the ferry cost to balance those. At some point, 2 times the ferry cost is just going to be strictly better, and I just would, for the number of remaining pairs, I just use 2 times the ferry cost. So I guess I should consider how many pairs are actually below 2 times the ferry cost. So for instance, let's say these are somewhat bigger numbers. Let's say this is 50, this is 100, and the ferry cost was 30. Then all I strictly care about is how many pairs can be ferried using themselves versus using the ferry cost, and add those two together. So let's say there were like some other stuff that was somewhat in between. Like let's say there was like a 40, 40, and a 45, 45, right? I want to balance the stuff using the 40 and the 45 rather than 2 times 30. Yeah, so what if the 40 and the 45 were on the same side? What happened then? So let's say this is 45, 45 over here, and this is like 50, 50 here. But I still use yeah, I guess it doesn't matter which side they're on because they're still canceling with something on the other side. That's not right. and they're always going to reduce the number of unbalanced stuff each time, because there's always going to be something that's unbalanced to cause them to exist, kind of. So it's the number of unbalanced things that are less than 2 times the ferry cost, and then for every remaining pair, I have to use the ferry cost. Okay. Sure. Huh. Okay, so how to do this? So I guess I can count the number of remaining pairs. Count of unbalanced pairs. And that'll be what? Count of remaining pairs would be for let's say it's maybe p for every value in my all counts, p plus equals, let's say counts 1 of this value divided by 2. And then I kind of need to know the sorted list of all the unbalanced stuff. I already sorted it. So it needs to be the sum of the number of pairs that are, so the number of pairs is the number of times I need to worry about the cost. Yeah, this is going to be a lot easier if I had access to the list of values. Okay. Unbalanced. I'll call this work values. And gosh damn it. Actually, I guess this is fine. Maybe I don't need to go through. Maybe I actually need to sort all counts. All counts was what? All counts is a dictionary. I need to go through the sorted version of all counts. Yeah, I need to go through the sorted version of all counts. So maybe minimum of all. No, this is not going to work. Minimum of all counts, not keys. Yeah, I should probably have created a set of all the. Okay, I think maybe all values is equal to all counts.keys, and make a list of that. And then sort it. And then I can just go through all values more explicitly. at that point, I'm not sure if I need to even sort the array 1 and array 2 separately if I have the array, all the values sorted here. It's probably still somewhat helpful. If counts 1 of this min value, I don't know what the max value is. I guess I didn't really, do I even care? Because it's always going to get swapped anyways. I don't know if this is strictly necessary. Okay, this is, okay, anyways, let's say all values here. Counts of pairs of unbalanced, count of unbalanced pairs. Okay, sure. Okay, so I have my sorted all values. Min value of all values, actually. So I have my assorted all values, and then I'll say that for every, so while p is greater than 0, let's use an index here. Well, actually, maybe I can just use a break in the for loop. For every index in range of the number of pairs, the length of all counts, length of all values. So I look at the stuff that's unbalanced in the all values. Wait. So I already removed it. So I think I need an answer value here. So I only care about this really if this value here is going to be a small value that is smaller than 2 times w. So if it's smaller than 2 times w, then I remove the number of pairs that it can remove. Okay, so if the counts, no, sorry, if the value itself is all value, the value itself is all values at this index. If this value is less than 2 times the min value, then I want to use it to swap. And the number of things that I'll swap with it is based on the number of pairs it has. Swappable is equal to counts 1 of this value plus counts 2 of this value divided by 2. So if there's 2 of them, I can use one of them to swap. And then used is equal to the minimum of the swappable amount and p, I guess, because I can't swap more than p things. And then answer plus equals 2 times this value, or not 2 times this value. So each time I swap it once. So it's actually this value times used. So if I have a 40 and a 40 and another 2 40s, then I can use 2 of the 40s to swap twice. So the value is 40, the number of times I use is 2. Yeah, and then p is decremented by the used. And then if p is ever 0, then break. because then I don't have anything else to swap if I need to. And then lastly, well, not lastly, but if they're okay, if the value itself becomes big enough that it's actually equal to or more than 2 times the min value, then the remaining stuff is going to be using the min value to swap everything from there on. So for every p you use 2 times w. Is that right? Or is it for every 2p you use 2 times w? Yeah, so I think for every remaining, actually, so there's 2 40s, then I said use is 1, or I said swappable is 1, so use is 1. So I used one of the 40s, but the number of unbalanced pairs is actually 2 times used. Because for each use, it's actually, okay, I think it's actually 2 times used here. And then here, if the value is bigger than the remaining stuff is using the 2w, and 2w gets rid of 2 pairs, so each w gets rid of a pair. So I think here it's going to be answer plus equals p times min value. Okay, here goes nothing. List sort. Oh, whoops, that's not how you create a list from something. Eek. Return zeros. Okay, let's go ahead and say, let's go ahead and print out counts 1 and counts 2 here. Oh, whoops. I returned answer equals 0 right there. Whoops. Answer should be initialized to 0. Okay, so let's go ahead and just print out everything. One, two, four. Really, everything got canceled. Really? How odd. Alright, I gotta take a bio break here. Where was I? So for some reason the values were all zeroed out. So go ahead and print out here. Value counts one of this value. It shouldn't have zeroed out. I don't think. Okay, there's two ones. Two. Okay, yeah. Excuse me. So counts one of the value. Counts one, so counts two. It counts one, the value doesn't equal 0. Array 1. Append the value. Counts 2 doesn't equal 0. Array 2. So array 1 should just be 2. That's the remaining unbalanced stuff. And array 2 should just be 1. Okay. Ah, it is in fact 0. Oh, I forgot to include the answer as part of this when I did the swap. So it's kind of answer should equal here. The answer should be initialized to 0, and answer should increment by whatever the min value is here. Same deal here. Okay. And the answer should not be reset to 0 there. Okay. Can hide some of these prints. I think I'm missing another print here. Ooh boy, that's not good. That's really big. So it seems like I should be using 8 as the balancing value here. If the value is less than 2 times the min value. What is the min value? Whoops. Did I add that to my test case? Yeah, I did. Min value is 8, sure. Okay, what is P actually? Is P something really large? P is 6. P times min value should have been done pretty much. The value, it's all values of index. The value swappable is counts 1 as min value. Counts 1 of the value plus count 2 of the value divided by 2. So 8 occurs 0 times. And then it goes to 14. Okay, I'm just going to go ahead and just print print, let's say the value, p, and the answer currently. The value is 8. The p, there's 6 pairs, and the answer is currently 0. And then the value is 14. 14 is already balanced. So I can't, so swappable should be 0 there. And then it becomes 32. Oh, I forgot to fucking break. So stupid. Okay, I was debating when I want to just do an else break there and do the remaining stuff outside the loop. Maybe I should have done that. That should have been the thing. And then answer plus equals p, the remaining p divided by, or p times the value. How do I delete? Oh my god, I can't remember how to delete one. Sometimes I just blank out of my muscle memory. Answer, okay. Okay, so bunch of all values, 98, 10, 1854. Ooh, off by 1. Off by 1. Interesting. That can be really close, or that can be really far away from an actual figuring out what happened incorrectly. Most of this is zeros. Counts on. Okay, I guess I just need to go through this step by step. There's 90 pairs I need to balance. No. Yeah. P is, no, it's printing out, P is the middle number, okay. 1854 pairs. Oh no, what is going on here? The number of pairs went down to negative. Swappable. Ah, I see. So I'm not counting this correctly. So I can't be subtracting 2 times my number used. So the number of pairs that need to be okay, so what am I doing here? So I should be getting down to like 2 pairs. Okay, so each pair, there has to be an even number of pairs, I guess. There has to be an even number of pairs that are unbalanced. Otherwise it wouldn't work. I think So there's one unbalanced pair there, another unbalanced pair there. One unbalanced pair, another unbalanced pair. So use should be maybe swappable counts for 2 times number of pairs. So for each pair, okay, so swappable is the number of pairs. The number of pairs of things I can use. There's 2 40s. 140 can be used as the swappable pair. And how many times I use it would be 2 times the number of swappable. No, this is not correct. So if the number of pairs was 2, so here ends up being that the swappable was bigger than the number of pairs. Swappable becomes used, becomes minus equals. So each swappable pair means I use up 2. So the minimum of swappable and p divided by 2. P divided by 2. So the swappable is 8, and I'm going to go ahead and remove 8. Yeah, I think that might be right. Okay. Try number 2 at submitting. Or, I don't know, what, try this 3, 4. Remove more prints, I think. No, that's actually alright. Okay. Alright. A solution is a solution. And the difference between my solution and some other solution, like 161 versus like 70, 80 milliseconds, is reasonable. I think there was another way. I think. All right, let's consider if I can maybe quickly identify a way to make this faster. It depends on just sorting it, kind of. So make my counter. I guess it doesn't. Does it matter where the pairs are located? Yeah, it does. So I have my counter. All counts of the value. I actually don't know if I ever use all counts of the value. Maybe I should say here, is that all I need is a list of all the values. So let's say, actually all values, let's say it's the set counts 1, and then all values update from counts 2. And then, actually, then you convert to a list, and then I need to sort the list. Maybe I just say here, all values dot add this value. And then all values add this value here. And then I can say all values is equal to the sorted version of this. Sorted of all values. I think that's right. Sorted returns a list from an iterable. Okay. I think I don't use all counts, do I? I guess I do here. If all counts. But I don't use all counts after this, I think. Okay, so I can just say for value total is equal to just the sum of the counts 1 and counts 2 of this value. It has a remainder of 1 divided by 2. Okay, I think this is still working all values. It's still going to work. But it might be a little faster because I got rid of some of the... It is slightly faster now. 124, 162. It's like 30% improvement. Even if it didn't really change where I am on the distribution, really, where my solution is. Track values that are still unbalanced. Guess I don't know if I need this. It's still pretty useful though to decompose this problem. Yeah. There are definitely better ways, or maybe faster ways of doing this, but it's fine, I think. I'm getting really graded on efficiency. Min value of all values. I guess I already sorted all values, so I can say min values is 0. If counts 1 of this thing is that, remove. I could probably just say counts 2. Oh, you know what? The default dictionary thing is probably pretty slow. But that's, I guess I can't really do, can't do a static array or a fixed size array because this can be way too big. So for every, let's see, where was I looking at? So the min value, if the remaining counts did I ever actually use array 1 and array 2? What the hell's going on here? Don't think I did. Remove unbalanced stuff. Yeah, I did that and then I never actually used. I did remove it, but I'd never used the array 1 array 2. Guess that was a slightly different thought process back then, or at the time, before I realized I could just not worry about the particular values themselves and how frequently they were just need to iterate through. max value is array 1. I guess I did need that. So I did need to know the max value of array 1 and array 2 if I didn't sort it. So this would be max val max of counts 2 and max of counts 1. Okay. This should be a improvement. Got rid of. Okay. So now okay, I think this part I could also do within the other iteration for values. Remove unbalanced stuff. Count of unbalanced pairs is going to be p. So for all values, cancel, subtract. Do I even need to do that? Move it. I wonder if I can do this in one pass actually. No, I guess I need to do this thing right here first before I do the second pass of it. Okay. Do I need to modify it though? Did I need to modify it? Could I do this pass? Could I do this calculation before doing the counts calculation or doing the cancellation? Huh. Max. So if there's a min value here, counts 1. Actually, I'm not sure this is correct. How is this correct? Counts 1 doesn't equal, this thing doesn't equal 0. What if the max was balanced already? Counts 2. It just depends on the number of pairs, I guess. Yeah, just depends on the number of pairs. So I just should be counting the number of unbalanced pairs that I have to worry about and the number of values that are smaller than min value. Okay, I think it's my favorite sort set. So the min value, yeah, min value is always the min value. Yeah, this is actually not necessary. I can just treat it as the smaller of the two swap pairs. Okay, so I'm going to say min value equals the min of all my values. Don't really worry about whether or not it's balanced or not. So for all value, for every value, actually, I need to count the number of pairs. I need to know the number of unbalanced pairs first. So that has to be the starting point. So for every well, does it have to be the starting point? Yeah, I think so. Every value in all values, p plus equals. So the count of the unbalanced pairs would be, if I don't do the subtraction of the cancellation, it counts the difference, the absolute value of the difference between counts 1 of that and counts 2 of that, divided by 2. And then I iterate again with just the cancellation. So it's a little greedy in terms of just like removing stuff, hoping it works, but I don't think I even need this. Answer is originally 0. Min value is still min value of all values. And then for every index, all values at the index. Why can't I just go through all the values themselves? Because it's already sorted, right? Yeah, so I think I don't need to use the index here for value in all values. If the value is less than 2 times the min value. Yeah. And the swappable in this case is the difference divided by 2. Absolute value of the difference between them. Okay. See if it still works. Alright. Slight improvements. I mean, slight increases in percentage, but probably pretty drastic time performance improvements. For every value in basket counts. I think maybe I can even make this better here. Because I just need to know the difference, right? I don't need to know the actual placement of where they are. So I think maybe I can just do a single counts. That is the difference between them. Diff counts. So for every value in, I think it could be something like for every value in all values, the diff counts of this value is equal to the absolute value of counts 1 of the value minus counts 2 of the value. And then once I have that, then maybe I can just do the value. Actually, I could do this thing right here too. If the counts 1 of the value, oh, whoops. I haven't created my default dictionary at all yet. What am I doing? Oopsie, oopsie. For every value in basket 1. For every value in basket 1. Okay, actually, okay, I can probably use a counter here. Counts 1 equals counter of basket 1. Counts 2 equals counter basket 2. Actually, let's go ahead and create a frequency variable rather than this thing and relabel and have to possibly have incorrect code. Frequency 1 is the counter from basket 1. Frequency 2 equals the counter from basket 2. And then for every value in basket 1, so all values should be just the set. The set of basket 1 updated with the set of basket 2. Okay. And then for every value in all values, then the diff counts for this value is equal to the absolute value of so if the value is in frequency 1 and the value is in frequency 2, then the diff counts for this value is equal to the absolute value of frequency 1 of the value minus frequency 2 of the value. Else if the value is in frequency 1, then the diff counts of this value equals frequency 1 of this value, else diff counts of this value equals frequency 2 of the value. Okay. So I think I can get rid of this at this point. And I think this thing is just the diff count of the value. And absolute value of diff counts. So I think this is diff counts of the value here. Okay, actually I can do this in one step here. That's the whole point of what I probably was doing before I got to this train of thought. So if it's -1, if it's odd, then return -1 is not possible. Otherwise, increment by twice the difference, or half the difference, is the number of things. Okay, min values is just all values at 0 at this point. Now, and at that point, I can also no, I have to do a separate for loop for that. So P is the count of unbalanced pairs. And here's where I remove the unbalanced stuff. Or reduce for each unbalanced pair. Remove the number of unbalanced. there by the min value or twice the min value, or the smaller current value. That's poor explanation, but swappable will be just the half of the diff counts of this value. Okay, I think this is still correct. Basket 2 is misspelled. Hopefully. Did a lot of changes. Okay. Oh. Oh boy. Counts. I think I can delete these counts now. Diff counts. Okay, so my frequency counters. All values. Set up all values. Find the difference in the frequency of each value. And then sort the values. The smallest sorted value is your ferry cost. Count the number of unbalanced pairs. Could I possibly have done this here? Yeah, I think I probably could have done it here actually. Yeah, I could have done it within this first iteration. P equals 0. This is the count of unbalanced pairs. So here I can do something like if diff counts of this value mod 2 equals 1, then return -1, else p plus equals diff counts this value divide by, or just divide by 2. Yeah. So I can get rid of this one. All values is sorted. Sort list, get the first element. For every value and all values, its values times 2 is less than the value. Swappable is that, and then the number used is that. Answer incremented, p decremented. There's no more pairs, break, and then use the min values for the varying the remaining pairs. Okay. I think this is as clean. Could I have done this within this as well? No, I don't think so. Actually, could I? I could sort here, set up the min values here, and then iterate. No, because then I need to still know that I need to do this check right here, this -1 check for impossible things. I can't just assume that I can break early. Yeah, I think I need to do separate loops, but I mean, there are other ways that I can do it without doing separate loops, but I think it's fine to use separate loops. Slight decomposition at the cost of some time is fine. I think I optimized it. Satisfactory, optimized enough. Okay. Alright, so summary for this one is, I think this is kind of useful as demonstration. So basically, when you have two arrays, I think the original arrays were like what was it? 1, 5, 5, 1, 10, 10. 1, 5, 5, 1, 10, 10. So if you have two arrays like that, then the kind of instinct to balance them is to just take the smallest unbalanced thing and the biggest unbalanced thing and kind of do the swap so that the smallest thing is the cost of that swap. But here, if I swap the 5 and the 10, the cost of that would be 5, and that balances it. But the other idea would be if there is a smaller value that maybe is already balanced, then that small value can be used twice to kind of vary the two things that need to be balanced. So like this one varies the 10, and this one varies the 5. And now you have the 2 1 swapped and the 10 and the 5 swapped. So in essence, basically, if you have something that is of this form where W is kind of some small cost that's balanced, and BB and AA are things that are unbalanced, then you either swap based on the A and B, the smaller two values, or you swap on 2 times the small balance value. And really it's going to be something like this: min of this and that. And there might be instances where there are some pairs where you swap based on the smaller of their two pairs versus the smallest twice the smallest value. But then at some point, the twice the smallest value will do all the remaining swaps. So for instance, maybe this was 3, or maybe the smallest value here is 4, right? So you just want to swap the 5 and 10 with the 5 and 10 rather than swapping 2 4s. But if there was another one where it's like, let's say 20, 20, and 30, 30. So you swap the 5 and 30 to get rid of them, but then the 10 and 20 you swap using the 4s. So at some point, basically, whenever the min value of the stuff that's unbalanced is bigger than twice the smallest value, then you want to just use twice the smallest value for that pair and onwards. So basically, that's the main idea. All you really care about at that point, or in essence, is your difference between the pairs that are unbalanced and how many of them there are and the values of them. So that's what this early stuff is doing. So finding the values using sets, and then for every value, finding how frequently they occur in both arrays, find the difference into them because that's really all that really matters. And if the difference is not even, then that means that there's some then they can't be balanced at all. Like if there's 5 1 and 5 1 and 2 of the other ones, so there's going to be an odd one out. So there's never a possibility there. Otherwise, the difference that they have, half the difference is the number of pairs that are related to that. And then once you kind of have everything sorted out, you figure out what your min value is. That's going to be your ferry cost, like doing the double swap. And the value is going to be for every value that's remaining, or for every value that is that has a difference rate, then the number of differences that they occur, you kind of swap based on them. Okay, so summary is this is mainly it's kind of a math problem really. Simplify can greatly simplify calculations by only looking at the values that are, or the values that have different frequencies. in the arrays, tracking how many unbalanced pairs from those values for each pair to balance pairs. Consider that you can use the smallest value, smallest balance value in the array twice, or the smaller of the smallest, the smaller of the smallest and largest unbalanced pair values. Increment answer appropriately and decrement number of pairs that were removed. Also check for impossible for impossible arrays where some values have where values do not have even total frequency. So if there's like 1, 5, it's not going to work. Yeah. Time complexity, this is going to be O of n to iterate over all values to create frequency counts, and to iterate, actually, to sort, it's O of n log n, and you need to sort to quickly determine at what point or where your smallest values that you're dealing with that are compared to your bin value. Yeah, so sort is needed so that the smallest cost swaps are done first, and loop breaks when cost is such that any remaining pair uses the lowest value to do swaps. Alright, space complexity, this is going to be O of n as the number of uniques could be proportional to O of n to keep track of all values set to and sorted list of all values could be proportional to the number of values in an array.